here. So by taking the first derivative, and solving the inequality, you can find periods of increase and decrease. Now, we've already talked about this once before. We talked about the object moving forwards and backwards, and we did that example on Monday, I think it was. We said there was a car and we used an interval chart to solve it. It's very similar to the same idea here. If the first derivative is positive, that means that it's going up, the values are going up, and the values are going down. If it's negative, just like this graph is very, very rough, it would very easily tell you on this graph we have negative slope here until you get to this point right here, then you have positive slope, and then it keeps going up there. The same thing for this messy part there, right? You'll be able to tell very, very easily when those values are, okay? And it's not always in the middle. So know what you're thinking. You're saying, well, it's got to be in the middle of this and this. It's not always for higher order functions, right? So for parabolas, it's the middle of the two roots, but not always for higher order. Okay? Okay, here we go. Now, another thing I want to say, I should probably pause when I'm saying this. Luke, I'm going to embarrass you. You're talking a lot of bad smack about graphing. Don't talk smack about graphing, okay? This is meant to make your life a whole lot easier. It's meant to, okay? Graphing's like the visual representation of all the algebra that we've done so far. And I've lasted, it's May the 3rd right now, my niece and my nephew's birthday. Here's a joke though, like my brother really wanted his kid to be born on May the 4th. He's a Star Wars nerd, yes, okay, sure. So he really wanted to be May the 4th.
Close.
May the 4th.
Dressed up as Darth Vader on May the 4th.
He is like the coolest guy I've ever seen in my life, I bet. And I guarantee she said yes there. Who could say no to Darth Vader? Here we go, example 1.
Yeah.
Show using algebra. The periods of increase and decrease. For f of x equals 4x cubed plus 5x squared minus 2x plus 1, and use this to help sketch. Now, I'm going to say this and I'll single anyone out. Let's just say that factoring is very important in this unit, okay? Very, very important. Factoring cubics from grade 11 or from advanced functions, and also factoring quadratics. If you forget how to factor a quadratic, what can you do if you're like freaking out on the test? You can always use the quad formula if you're freaking out, okay? But if I say find the roots of this, there is a cubic formula, but Mr. Count printed it out once at size 3 font, and it took like the whole front of the blackboard like to do, right? So, yeah, so you're not going to memorize the cubic formula, okay? Maybe it's not actually that long. Maybe it was the quintic formula I was thinking that was that big. But the cubic formula anyway it's a lot more impressive than negative e plus or minus. All right, here we go, solution.
Yeah.
Okay, what's the first step in taking this? Well, we need to find f prime of x. I got a brave soul named Cecilia to find the derivative of that starting function for me, please. Very good. Okay, so what do we need to solve? What do we need to find here now? Roots of this, okay? So you're going to solve 0 equals 12x squared plus 10x minus 2. Right away for this question, what can you instantly do and why? Divide by 2 because they're all even. Why can't I just scrap it in this case? Well, because it equals 0, you're just dividing by 2, right? So I can say 0 equals 6x squared plus 5x minus 1. Okay, now I'm going to do this. I'm going to take my time on this because I want to make sure that everyone understands what's happening here. Okay, that question? Go ahead. The what? I'll write it here, so I'll show you what I did. And then I said, well, if I divide both sides by 2, they just disappears, right? You know what I mean? Like that, and get rid of a 2 on that side. Okay, so just humor me and let's do the M and the A factoring all the way back from grade 10. No, Solinger, I know you're in my class from grade 10, so you're an awesome M and A factor. What's the M, what's the A here, please? Uh-oh, he's forgotten? Yeah, it is. Okay, but I'll write this out first. It's not 3 and 2, but think about that while we're doing this. So we're going to multiply to negative 6, we're going to add to 5. Where did I get the negative 6 from? Where did I get the negative 6 from? Yeah, go ahead. Yeah, that's what the answer is actually going to be, is negative 1 times 6. But just as far as that negative 6, that came from this times this. The two outside things turned together. The A is that. There's an easy way and a hard way to do this. I'm going to choose the easy way. As I get this far, this is the key step to factor analysis. Why am I happy at that moment? Why is that looking good?
Because you could put the x plus 1.
Yeah, what I was hoping you were going to say, that is true. What I was hoping you were going to say is that there's 2x plus 1. There has to be the numbers that are the same. You guys are in calculus, you don't need me to tell you this. Okay? So I'm going to say 0 equals x plus 1 and 6x minus 1. When I find my roots, I get x is equal to negative 1. And I get x is equal to 1/6. Okay, now I'm going to give you a second to write that down, and then I want to talk about what these points actually mean, because this is what you need to understand. It's one thing to be able to do the math one side. It's one thing to be able to do the math, but it's two to make sure you understand everything. When x equals, sorry.
I'm not just gonna like say what I
Yeah, go ahead. Yeah.
like. Does that mean like the end of like the parabola kind of things?
Yeah.
They're gonna hit those numbers?
Right on. This is when your slope is equal to 0, is what I was going to say, right? So you're exactly right. That would be like if it was dealing with a parabola. That would be that point right at the top of the bottom, okay? So if we're dealing with something like this, so it looks to me like this graph's going to be something like this. You're going to have one point like that and one point like that. Okay, that's what this graph is going to look like. And it makes sense because it's a cubic, right? So you should have two local max and local mins. Now time for an interval chart. Don't say darn it. So I'm going to write my f of x. I'm going to write, what am I writing for my f of x? Nathan, go ahead. Yeah, what I write there, please.
X plus 1, 6x minus 1. Good.
And I do an overall in the test. That's why I write it, because I'm a math teacher. If you do it a different way, that's fine. And if you did this a different way in advanced functions, I have no problem with that. Do it the same way you did in advanced functions. It's going to be similar, I would anticipate. All right. Emma, how are you today? All right. Can you tell me what to write for my intervals, please, on the top? Yeah. I didn't hear the end part, but I'm assuming that's what you said for that. Now, some people asked me on Monday, they said, do you want me to write to infinity? You don't have to. X is less than negative 1 implies that it goes to negative infinity. Okay, so you don't need to write that. All right, test point. I will pick these. Negative 20, 0, and positive 20. You can pick anything in that range. Normally I try and choose integers, okay, right? But if you want, you could say negative pi and things like that. Don't do that to yourself, though. Just leave integers, okay? Negative 20 plus 1 is a negative. 6 times negative 20 minus 1 is a negative, so that's going to be a plus. 0 plus 1 is a plus. 0 minus 1 is a minus. And then 20 plus 1 is a plus, and a plus, and a plus. Okay. I'm going to put on here now another chart here for what F, sorry, for F, called F of X. Okay. So if we learned, okay, so what did we learn from that interval chart? Let's talk for a sec. What did we learn from that interval chart? What did that tell me, the plus, the minus, and the plus? Chris?
That when it's less than -1 and when it's greater than 1/6, that it's going to be on the positive side of the graph.
It's going to be, well,
Or
not
it's going to be on the
graph.
positive y part. Yeah, it's going to be
increasing on the positive, because, again, we could have a graph that looks like this, right? And that would still work, all right? So what I'm saying is here, this is sort of like the shape at the end here. All you're going to say is that this is going to be increasing at that point, okay? From here to here, it's going to be decreasing. From there to there, it's going to be increasing. That's just going to help us draw the graph. And if you want to do a curve, you can do it with a curve, okay? A very, very rough graph for this would be then now. This is going to be a rough sketch because I want to do lots of examples today. At -1, there's -1, there's 1/6, and that's it, okay. So what I'm saying is here, we don't know the zeros, but it's going to be going increasing up to this point, then it's going to decrease, oops, let's try again here. Then it's going to decrease to this point, and then it's going to increase like that. Okay. We'll do these in detail in a few minutes here, but I just want to get the idea there for the increase and the decreasing.
What is the, oh,
So from, just so we see that, okay, it's increasing until it gets to -1, then it decreases until it gets to 1/6, and then it increases again. Okay? Yeah, you would have to do a detailed graph. It's just a rough sketch for this right now. Okay, so you could find your x-intercepts. The thing that I was going to try and say though is there are graphs. This could be a graph with only one x-intercept, and you wouldn't be able to find these points, right? You could find a test point, and we will, when we do a formal graph, find f of -1 and f of 1/6 to find exactly where those turning points are to get a good idea for the graph. So I want to do one more of these to make sure we're feeling sort of. I think it's 5 after 12. So I'm gonna go watch on me.
It's 9:41.
Okay, perfect. Just terrified there for a second. Yeah. It doesn't. I mean, if it could, but this is just a rough sketch, so I'm just trying to show the how's this. Hold on a sec, just wait. So.
That was bad.
This might be easier for you guys to get then, so there's 1/6, right? I'm just trying to show you the, you know, it doesn't matter where the x-axis is, okay? We're just trying to say we're going up and down at those points, that's all we're saying. Does that help a little bit, right? Okay. Example 2. Oh, here we go. All right. Example 2 says a box is to be constructed from a rectangular piece of cardboard that measures 12 by 18. The way this, I'll just draw the picture instead of writing out in words. Okay, so let's say I give you a cardboard like that. How would I make a box out of that cardboard? What would you have to do? Has anyone ever taken a box and stepped on it? You flattened it out? It's not a rectangle, right? What shape is it?
That's where it's not on.
Oh, nobody has? So. It is like a cross, right? So what's going to happen is you're going to have to take out something like this, right? And then you fold up 4 sides, right? So like imagine this is a piece of paper, Do I have a box I want to step on? Not really. Okay, right, but the idea is you're going to fold up these two sides like this, and these two sides like this, and it's going to turn into a box. Can everyone visualize that? Yes? Okay. I'm going to give you the equation. Later in the course, you'll have to make up these equations by yourself. So we're going to say the volume of the box is V of x equals 4x cubed minus 60x squared plus 216x, where x is the distance cut out. All right, it says, I'll get out of the way here. What is the domain of x? Okay, this is one question where domain actually matters for you. So we just have to scribble. You guys good back there? Good? Graphing, I hope? Okay. So just think for this. What's the maximum that you can fold this thing up to? What's the maximum distance that we can fold? We'll start again. What's the minimum distance?
0.
0. Good. What's the maximum distance going to be?
2.
No.
Well,
No. No. Well, think if I have a 12 centimeter piece of paper,
3.
what's the most that I can fold?
We have to go to
6, right? Because when we have it, right? So I'm going to say my domain is going to be,
But where's the bottom box then?
well, there would be none. So that's what I'm going to say 0 is less than x is less than 6. If you want to call less than or equals, I'll take that too, but that would have no box. If I fold it up 0, that's just a flat piece of paper, so there's no volume. If I fold it in half like this, that's going to be no volume as well. Okay. Letter B says,
Let's see.
evaluate V of 2. Explain what this means. Okay. I'm going to pick on my good friend James once he's done writing this down. Don't put yourself down. Yeah.
I believe you,
Listen,
James.
you're going into computer science, which means you're going to have to solve a lot more difficult problems than V of 2. Okay? So you can do this. What does V of 2 mean? What do we do? Okay? So it's going to be V of 2 equals 4 times 2 cubed minus 60 times 2 squared plus 216 times 2. Let's see how good my math brain is. 8 times 4 is 32 minus 240 plus 432. Someone confirm that for me. 464 or 224? Somebody said yes? Okay, so all I did there was I just used my calculator brain and I typed that in. Okay. James, you're not off the hook yet. Computer scientists don't just sit in front of the computer and solve problems. They solve problems for other people. What does that mean? What does V of 2 mean? Okay, somebody can, go ahead, James. James, don't put yourself down, you can do this. Somebody help me here. Austin, go.
The boxes sides are folded up like 2.
Right on. And 2 centimeters is folded. The volume is 224 centimeters cubed. Okay? So all I'm saying is for this one, James and everyone else, I take 2 centimeters, I'm just folding it like this on both sides. Okay, so that's only 224. Back from grade 9, what's the optimal shape going to be? From grade 9. A cube would be the optimal shape. Why is a cube not going to work in this scenario though?
They have uneven sides.
Right on. And that's what you're going to find in calculus, so they'll never have even sides. The optimum shapes are circles or spheres and cubes, okay, but unfortunately they're going to give you weird shapes. else are there? You're losing volume. You know what I mean? You're losing. Yeah.
Less, not.
Okay, letter C. And this is what you guys are going to solve this one for me. Determine the intervals of increase of v of x. And this is what you guys are going to solve for me. Because what the volume, v of x is your volume. So what we want to do is our volume is going to rise, rise, rise as we continue to cut. Eventually we're going to get to a point that if we keep cutting more, your volume is going to start dropping, right? So all we want for this is we're really solving for v of x is equal to 0. That's what we want. That's going to be our maximum. But because we're talking about increasing functions, we're going to ask for the interval when it's going to be increasing. Okay, so go ahead and solve it right now. V prime of x, solve it.
Actually, don't know this one. Just switch it around.
V prime is like your rate of change. Well, it doesn't say that, but okay. The increasing, no, just wait. The increasing of v of x means v prime of x. Right? Because v prime of x is what's being increased.